All right, welcome back, everybody. This is Wednesday, the 14th, and engineering problem solving. And I'm going to review projection. I'm going to review hidden lines, oblique sketching, and making sure that you all know to name your views. So I've gone through all the homeworks, and I want to say nice job, everybody. This is not It appears to be easy stuff, but to get all the details correct, it's not that easy to do. It's a very big attention to detail exercise that we're going through, and these are simple ones. So, not forgetting hidden lines, that's a big thing, or missing hidden lines. Not understanding projection, we need to understand projection. So I want to go through some of this stuff, and then I'll do a little bit of an example sketch with you a little bit, and then I'll push you off into your next exercise. So, if you missed a big chunk of the assignment and you want to submit, I'm going to let you do that, just because this is a weird way to learn. Usually I do this in lab. I have you sketching in lab. I can look at what you're doing and correct that problem right away. And now it's like a 24-hour, 48-hour feedback loop that's just not great for learning. So if you want to resubmit, let me know you're resubmitting, and I'm more than happy to relook at stuff and give you some points back. My goal is not to take points away. I want to give points. So there you go. Let's talk about projection. What the heck is projection? Some of us seem to have it down, and others have views floating around. So we have to lock these views down. I'm going to use the book for this because it has some good examples. All right, so I'm flipping you around. All right, so projection is when views line up, they project to each other. So, for example, this is a good example of projection. You can see our object and you can see the views. So, if your view is the front view, and these edges are visible, then they're visible lines. We kind of have that down, I think. This develops the front view right here. And that, on our paper, is right here like this. There's our paper. We're not working with left or the rear or the bottom at this point. We're just working with the front, right, and top. That positioning is critical. This is the positioning I want. Front view, right side view, I don't know why this is all weirded out here, and top view. It's like they have a printing problem. Okay? And notice that the bottom of the front and the right side line up with each other. That is called projection. This hole projects over and creates hidden geometry in the right side. Because when I look at this from the right side, I cannot see this hole. I cannot see it. So that's when we want to develop hidden lines. When I look down from the top, I cannot see the hole. It develops a hidden line in the top view. When I look down from the top, I can see the slot. So the slot is visible. So a few of us are missing some hidden geometry. And for example, this hidden line, what is that from? Looking at the right side view, what is that hidden line from? If I look at the right side view, it kind of looks like a big L shape. That's all I can see. But back here is this notch, and that's what this hidden line is from. Big L shape is good. I cannot see the notch. That's what this hidden line is. All right. So it is a puzzle for you to solve. And it's very important that we don't miss any of these geometries. You'll see they put some center lines in for holes. That's perfectly fine if you want to do that. That would be used for location. And then this center line in here for this hole. Okay, so projection means a geometry in one view, let's say the circle, projects up and creates some kind of geometry in the top view. that circle also projects to the right side view and creates some kind of geometry. It might be a hidden geometry. It might be a visible. For example, this slot in the top view projects down to the front view, but it makes a visible line. So that it's your job to figure out, like, hey, that's visible, that's not visible, right? And it is a game. Like, it is very difficult. And it takes practice, so we're going to practice a lot. All right. Notice also, just focusing on our views, which is front, top, and side, they actually have labeled their views. I need you to label your view too, okay? That's a requirement. We have to have our views labeled. So as you send me drawings, as I send you drawings, we understand that we're all looking at the same views. All right. Now I would like to, I'm going to zoom you back a little bit, just do a little sketching exercise out of the book. And I'm going to use number 3, and I'm just going to go through it and create a sketch of number 3. Okay, I don't have any tick marks here because I think on this exercise they actually have you use your scale and measure it. So I'm just going to estimate those sizes of number 3. Okay, and I'm going to try and give myself enough room and not work off the, off the paper. So I'll try to pay attention here. So this is just an example problem of number 3. Remember that we're going to use the same front view for all of us. Here's the front view. That's going to be consistent for everybody. So the front view consists of a long rectangle that I can see. So the way I do this is I kind of start with what I can see, and I'm going to just proportionalize this thing. So it's fairly long. So I'm going to make it pretty long. And maybe that's going to be too thick. So I'll leave that side, and this side I'll drop down. I'm going to go like 1.5. Again, I would want to take my time and figure out, the exact proportions of this. But this is how I might start with my front view. Now I may run out of space here, but I'm doing it in a pretty small area just so you can see how I'm doing this. But this is how I start to create a sketch. I can see this full rectangle, right? So I know it's going to be a full rectangle. I can see this edge over here. Even though there's a round there, I can't see the round in the front view, but I know it's there. But this back edge is this surface out here, right? And then up here, it looks like it's a vertical up for a bit. Looks like maybe double this, so that's what I did. And then it goes around, so it looks like it is about halfway. I don't know. I'm going to say halfway up into here, right? And then the height of it, maybe twice of this, I don't know, in here somewhere is just a guess using proportions, right? And then I know that, I'm going to kind of box this in because that's good sketching technique, right? And I'm going to figure out that it comes over and it has a little straight to it. So those are the kind of things you want to really, there's a little straight there. That's the thing you want to observe. And then this is the upper part. So I'm gonna try to do my best quick sketching. If I was doing this for guys in a meeting, this might be how it would turn out. If I'm doing it in my office, when I have more time, then it might get a little prettier, right? And then I'll come down a little, because I come down a little. Then it looks like, right, I have a fillet in here, and that's going to be seen from this view. So just focusing on that front surface. Yeah, looks like I ended up maybe this a little bigger than this, but good enough. That's how I start to develop the sketch, is I really focus on one surface or one view. Now there's a hole here, and I see the hole from the front, so that's going to go in here somewhere. And I like to create, of course, a box to put it in, because that's just good sketching technique. And then I would go for the circle to keep it nice and round. All right. Front view, is it done? I think that's all the visible geometry, right? So then the next thing you want to think about is there any hidden geometry? Like, is there anything from this view, the front view, that I can't see? Yeah, there is, that hole. So I position that, and then I'm just going to guesstimate here. And hidden geometries create hidden lines. All right, so the front's done. Now I can start to build the top. So that's easy because I know this side lines up and this side lines up. And I can just draw a line to start with because I think from the top I will see this whole surface. So now my view is here, right? Top, looking down. I see this whole edge, and actually the whole drawing for the top view is a rectangle with a curved surface right here. So I'm going to draw that rectangle in. I'm going to run out of space. So I think we're pretty close to the right proportions. Right? So I draw that rectangle. That contains the top view, right? And I know there's a radius in here, so I'm just going to put that in. Notice that there's no visible line down for that surface change in the front. That would just be confusing, so you don't include that. Then I pull this corner out, and any time that I know material is missing or gone, I want to make that correction right away, right? Because that's going to help my eye see the view. Then I just start to focus on what do I see from the top. From the top, oh, I see that circle. So that means that this projects up. This side projects up. Looks like it's kind of in the center. That's what I'm going to draw. Right, and creates, so those sides project up from here, and that creates my circle that I can now kind of just sketch and really pull it out and get it nice and circular. Good enough. Right, from the top, I see that circle. From the top, I see the top edge of this entire curved area. So this projects up and actually does create a shoulder because there's a little flat here that I see. So that's actually this little space we're seeing, and I do see this kind of flare out, this edge, this entire edge, right? So that comes along and it kind of goes out to here, right, about to there. That's what I see from the top as far as the visible lines and the visible edges. What can I not see from the top? I cannot see this hole. When I look straight down, I cannot see the hole. So I want to project up and project up. All right. And it wouldn't hurt to plop in a center line. Yeah? Everyone kind of get that? And then I could continue on and do the right side. I don't know if I can get it to fit in here. I'll put it close. Right side, it's not very, it's this wide, right? The right side, so maybe I'm too wide there. And I know that this surface is going to project over, right? And I'm going to see that entire surface when I look from the right side. I see this rectangle, and I see kind of a long rectangle up and down. So I'm going to see on this edge over here, because it's back to the, if I look from here, it's to the right side. So it's over here, and it's this tall. So once you get views, you actually have some things to work with. This line, visible surface, comes all the way across. It comes all the way across there. Okay? So I have the beginnings of what I see. This curls away. I see that in the top view, but I don't see it in the right side view. And what else from the right side do I not see? I think I have everything that I visibly can see. I don't see the holes from the right side view. Can't see them, So they become hidden. It looks like it's in the center, so I'm going to plop it in the center, kind of. Just estimating everything here. This one I can project across, right? That center line would line up with this center line. We don't connect them, but they would line up. There would be a center line here. All right. Hope that helps. Just working through one that we haven't done together and trying to make sense of it. All right, let's talk about, I'm going to flip you up and go to the big board. See if I can get it on screen. Oh, not bad. Getting better at that all the time. And talk about our three-dimensional sketching a little bit, because there was a few mistakes in that. So, not many. Like, they're really good, you guys. I was very impressed. But let's talk about ISO versus oblique. So everyone seemed to have ISO down. ISO starts with this kind of an axis. It can be flipped over, but an isometric sketch kind of has equal depth to it, right? Like that. So that's an ISO. Really, these should all be the same height, and I think they are, but the camera looks like it skews it a little bit. So I don't mean to have this shorter than this. It's supposed to be the same. So, to make it look right on camera, let's see if I can get it up higher. Oh yeah, that looks better. Like that, right? ISO. ISO. Now, oblique uses a flat front, which everyone got just fine. Starts with a flat front. So it's like drawing your front view, right? Then off at an angle. And you can change the angle as you need. You can make it flat or you can make it steep. But the depth of the object gets an angle to it. And it gets it consistently throughout the object. So this would be oblique. So a few of you missed that. So just look back over that if you want and make the correction. Whip out a new little sketch if you want to get some points back. Okay? All right, nice job, everybody. We're going to practice this kind of sketching, and we're going to add in some orthographic with it. So we're going to make a three-dimensional sketch, and then we're going to create the front, top, and right side view of your sketch. And you get to decide what your sketch is. I'm going to ask that it is a tiny house or a shed cabin, however you want to do that, but make it small, not a big home. So, for example, if it was like a 8 by 12, then this would be 8, this would be 12, right? And then this is an ISO, and I'm okay if you want to use an ISO or if you want to use oblique. Totally up to you. It's going to take some erasing, but you're going to start with the basic shape. If you want to make your square, you can, but keep it in proportions. So 8 by 12, 12 by 12, whatever you want. It's got to have a door, it's got to have windows, it's got to have a roof. All those things. That's it. Okay? And if you just stick to our rules, you'll be able to, and you should figure out how big that door actually is, but just notice that I'm keeping vertical lines vertical and horizontal lines horizontal. So, got to have doors, it's got to have windows, and it's got to have a roof. So if you're going to put a pitched roof on it, you got to think about, like, how am I going to do that? And I'll use a different color for the roof. But most roofs kind of come over, right? Like this. This is a pitched roof. And they hang over both out the back and out the side. So the roof somehow has to hang over the back and the side because that's usually how it's done. So that'll be a little tough for you to do. You could do a shed roof. So, a shed roof would look like a taller wall and a shorter wall. So this wall would be shorter. this wall would be taller, right? It ends up something like this. A shed roof. Totally up to you. You can choose your roof style. Just make your three-dimensional sketch as nice as you can. Okay. So it's got to have, you know, a door. It can have more than one window if you want. Doesn't need anything else. We're just going to keep it like that. But then once you get it designed three-dimensionally, you're going to create a front, top, and side view. So you can choose what the front is. You can call this the front, this the right side, and then a top view, which is going to be what's called a roof detail. Okay? Include your hidden lines. Include all the geometry that you have in your tiny home or shed. Up to you. I think this will be A7. And I'll put the assignment up, and then I'll probably say refer to this video for it. Okay? So then this would be on one page. And then on another page, let's see if I have enough room up here to the left. On another page, what you'll have is your front view, your right side view, everything in projection, right? Maybe a window here, maybe a door here. And then a top view, which is going to be your roof line. All right. I'll let you work your way through it. Good luck. Nice job. Stick with it. If you have any questions, don't forget to email me. Take care, and I think we have a quiz on Friday, so check the calendar on that and don't miss it. All right. Talk to you later.